I'm going to start a new series of videos around Ansible and how it relates to the Dell networking operating system. And instead of me trying to come up with my own interpretation of what Ansible is, I'm going to read a little bit of what Wikipedia has to say about the Ansible software. This article is about the software named Ansible. Okay, so it's a suite of software tools that enables infrastructure as a code. So this is key, being able to configure, manage devices remotely. But I think I'm getting ahead of myself here. It is an open source, and the suite includes software provisioning, configuration management, and application deployment functionality. And this is what I'm going to be covering on the labs about Dell and Ansible, being able to provision, to do some type of configuration management after the fact, and application deployment. In this case, I'm not going to deal with application deployment because I am just concentrated on the networking portion, but I can see how people can deploy applications using Ansible. Originally written by Michael Dehan and acquired by Red Hat in 2015, Ansible is designed to configure both Unix-like systems as well as Microsoft Windows. Ansible is agentless, no agents, relying on temporary remote connections via SSH, so that way we have a secure connection, or Windows Remote Management, which allows PowerShell execution. Okay, so it is a tool that will allow us to provision, configure, and many other things. The Ansible control node runs on most Unix-like systems that are able to run Python, including Windows with WSL installed, and the system configuration is defined as in part by using its own declarative language, which is human readable. And then the history. The term Ansible was coined by Ursula K. in her 1966 novel. Well, this is interesting. You can read it. And refers to a fictional instantaneous communication system. The Ansible tool was developed by Michael Dehan, the author of the Provisioning Server Application Cobbler and co-author of the Fedora Unified Network Controller FUNC framework for remote administration. Okay, so I can see where this is going. So the architecture real quick, the overview. Ansible helps to manage multiple machines by selecting portions of Ansible inventory stored in simple ASCII text files, and this is the key right here to make it simple. The inventory is configurable, and target machine inventory can be sourced dynamically or from the cloud-based sources in different formats. In this case, one that I have read about is the YAML format, YAML, and I just have to read about this one. I'm not really familiar. It's INI. Sensitive data can be stored in encrypted files via the Ansible Vault since 2014. In contrast with other popular configuration management software such as Chef, Puppet, Salt, and the CFE engine, Ansible uses an agentless architecture, meaning that we don't need to have an agent on a managed device. with Ansible software not normally running or even installed on the control node, in this case the managed node. Instead, Ansible orchestrates a node by installing and running modules on the node temporarily via SSH. For the duration of an orchestration task, a process running the module communicates with the controlling machine with a JSON-based protocol via its standard input and output. So this is a key, using this JSON-based protocol via its standard input and output. When Ansible is not managing a node, it does not consume resources on the node because no daemons are run or software installed. So I don't know how to pronounce this one right here, but it's DAEMONS. Okay. Dependencies. Ansible requires Python, so this is key. One thing, I was looking at the operating system, the Debian version of Linux used by Dell operating system. There is support for Python. Therefore, we can use Ansible and configure the Dell switch because this is already part of the Linux operating system to be installed on all managing machines. Okay, so that's fine, including PIP package manager along with configuration management software and its dependent packages. Managed network devices require no extra dependencies and are agentless. So this is key. This is one of the beauties about this software, that is human readable and that it doesn't require any processing power when it's not being used, and it doesn't require us to have an agent on the managed devices. But there is a need to have a control node. In this case, it can be a machine, it can be a workstation, and the control node is going to be the master host. It's intended to manage, orchestrate target machines. Nodes term as inventory. Control nodes are only available for Linux and the like. Windows operating systems are not supported. So this is something to consider, right? Multiple control nodes are allowed. Ansible does not require a single controlling machine for orchestration. Ensuring that disaster recovery is simple, nodes are managed by controlling node over SSH. So this is really cool. And then over here it talks a little bit about the design. The design goal of Ansible include whatever minimal in nature. Management systems should not impose additional dependencies on the environment. So this is one of the key pillars that the developers of this Ansible software considered. Consistent with Ansible, one should be able to create consistent environments. So that's another tenet. Secure. Ansible does not deploy agents to nodes. Only OpenSSH and Python are required on the managed nodes. Reliable. When carefully written, an Ansible playbook can be idempotent. Wow, this is a new one. What does that mean? Let's check it out. Alright, so let's see. Meaning, denoting an element of a set which is unchanged in value when multiplied or otherwise operated on by itself. Interesting. To prevent unexpected side effects on the managed systems. Yeah, so that's one thing you don't want to do. I mean, you want to be able to do changes, but do not mess up or corrupt a device operating system or operating functions. It is possible to write playbooks that are not idempotent. Wow, this is a new one. Minimal learning required. Playbooks use an easy and descriptive language based on YAML and Jinja templates. And of course, once we have our control node, and then the modules are basically another piece that has to be talked about. In this case, the modules are mostly standalone and can be written in a standard scripted language such as Python, Perl, Ruby, Bash. One of the guiding goals of the modules is this word right here, which means that even if an operation is repeated multiple times upon recovery from an outage, it will always place the system into the same state. Lovely, lovely, lovely. Inventory configuration. The location of target nodes is specified through the inventory configuration list, INI or YAM formatted, and they are located at the /etc /ansible/hosts on Linux. The configuration file lists either the IP address or the host name for each node that is accessible by Ansible. In addition, nodes can be assigned to groups. Okay, so I understand that. So in this case, an example inventory INI format, we have an IP address of 192.168.6.1, and then below we have the web servers. In this case, we have two, the foo.example.com and the bar.example.com. This configuration file specifies three nodes. The first node is specified by an IP address. Okay. And the two nodes are specified by host names. So you can do it by number, IP address, or you can specify by host names. Additionally, I'm gonna repeat this again. The latter two nodes are grouped under the web servers group. Okay. Ansible can also use dynamic inventory script, which can dynamically pull data from a different system and support groups of groups. Interesting. And then you have the playbooks. Playbooks are YAML files that store lists of tasks for repeated execution on managed nodes. Each playbook maps associates a group of hosts to a set of roles. Each role is represented by calls to Ansible tasks. Okay. And then you have the Ansible Automation Platform. The Ansible Automation Platform is a REST API web service, web-based interface application designed to make Ansible more accessible to people with a wide range of IT skill sets. It is a platform composed of multiple components, including developer tooling, an operations interface, as well as an automation mesh to enable automation tasks at scale across data centers. So this is a very powerful tool. Now, I have heard about Ansible before, but I just haven't been able to dive deeper. But now I have to dive deeper because it's a tool that is gonna save me a lot of work, a lot of having to enter information on a switch by switch basis, when I can actually do it from a central location and then just push the configuration files to the managed nodes. AAP is a commercial product supported by Red Hat, but derive 17 plus upstreams, open source projects, including the AWX upstream project, formerly Ansible Tower derived from, which has been open source since September of 2017. There was also another open source alternative to Tower, Semaphore, written in Go, which this is obscure to me. I don't know what it means, but eventually I will be able to learn what that means and incorporate it into my knowledge. Platform support. Then the control machines had to be a Linux, Unix host, And the examples I already mentioned: BSD, CentOS, Debian, macOS, Red Hat, Enterprise Linux, SUSE Linux Enterprise, Ubuntu, and Python 2.7 or 3.5 is required. And then it says here the managed nodes, if they are Unix-like, must have Python 2.4 or later. For managed nodes with Python 2.5 or earlier, then there is some package that can be used for that. And so there is, but I don't have to worry about that because we are using a current environment on the Dell operating system 10 and Sonic. And so this is the first video. It's composed of 7 modules, and before the first one is a lab overview explaining a little bit about the different pieces that make this lab, as well as an explanation about Ansible. The module 1 is to download, install, and set up Ansible. The second module is an introduction to Ansible network collections for Dell. Networking. Module 3 is configure hostname and VLAN using Ansible modules. Module 4 is to build a layer 2 VLT fabric. Module 5 is to building a layer 3 fabric. Module 6 is building a layer 3 VXLAN EVPN fabric. And module 7 is going to be about building a VXLAN EVPN fabric with symmetric IRV. And finally, the conclusion, and this is ends up this first overview about Ansible, what it is, and then I'm gonna prepare the following labs that is gonna show how this thing is installed and how it's actually used in a real deployment and configuration of a fabric.